Avi Loeb is an astrophysicist and professor of science at Harvard University. He's known for his views on our famous interstellar visitor, Oumuamua, and is founder and director of the Galileo Project, a coalition of scientists who plan to use special telescope systems to record data on UFOs and release it to the public via scientific journals. Avi has written several books, the most recent of which being titled Extraterrestrial. All right, well, Avi, straight away to start us off, tell me where you're from, because obviously I pick up on the accent and I've tried to guess and place you, but I haven't been able to get it.
Yeah, so in fact, you can save a lot in introducing me because I'm fundamentally a farm boy. I grew up on a farm in a village near Tel Aviv in Israel. And I used to collect eggs every afternoon. There were two aspects of my childhood that shaped me later on. One, that I was connected to nature, and I used to drive a tractor to the hills of the village and read philosophy books. And so I was much more connected to nature than to people, which still holds today. I don't have any footprint on social media. I don't care how many likes I get. And for me, frankly, we will discuss it later, but if I find evidence for a smarter kid on our cosmic blog, I don't need to convince anyone. I will just be happy knowing that, because all I want to know is what nature is about. Okay, and nature includes the universe at large, not just what we find on this rock that we call Earth. I just participated in an interview on C-SPAN a couple of hours ago, where one of the listeners asked me, why do we need to consider anything beyond Earth? And I said, that's a very narrow-minded point of view, that, just because we were born on this rock that happens to be orbiting the sun doesn't mean that, we should be that narrow-minded. There is a universe out there which is 10 to the power 19 times bigger than the size of this rock. And, it will just be unfortunate if we were to miss the big picture. And there is this cosmic play that was going on for 13.8 billion years. And our recorded history, the human history, is recorded for 10,000 years. That's 1/1,000,000th of the age of the universe. And, how can we even imagine that we are central players in this cosmic play? Let's try and look for other actors and ask them what the play is about, because we are really, we are secondary. We tend to think that we are at the center of the stage, that the universe is centered on us, that the Earth-Sun system is unique and special, and that's not true. Anyway, so my admiration to nature, my appreciation of nature started very early. And I'm less about schmoozing with people, impressing people, trying to get honors and awards from people. That's, in my mind, a relatively shallow objective in life. Okay, that there is much more out there that we can be inspired by, and that also drives a sense of modesty. We should learn from nature rather than assume that we know the answers in advance. Okay. And then the second thing is my interest in philosophy at a young age. I was interested in the big picture, but then circumstances brought me into physics. I had to serve in the military, and so I preferred to do intellectual work. So I finished a PhD in physics, and then eventually, after being for 5 years at the Institute for Advanced Study at Princeton, I received an offer from Harvard University that led to a tenured appointment there. And actually, over the past decade, I was the longest serving chair of the astronomy department at Harvard for 9 years, between 2011 and 2020.
Wow.
So I ended up realizing, once I was tenured, that even though it was an arranged marriage, I'm actually married to my true love, because astrophysics allows me as a scientist to address philosophical questions such as, what was there at the beginning of the universe, and whether we are alone, or maybe there are some neighbors in our cosmic neighborhood, and so it's really great fun to be able to apply the tools of science to these questions. And that's what makes me a bit different than my colleagues in some sense.
Yeah. It's a great mix that you've got, the inquisitiveness and the kind of philosophy thinking. combined with the scientific mind and the access to do things scientifically as
Yeah,
well.
I should say that social media, has a very negative effect on the independence of mind of people. When you look at you go to the beach and you see all the seashells that are swept ashore when they are relatively young, the seashells, just after they were put there, they have their own unique colors, but then over time they rub against each other, and as the waves go by, they end up breaking up to small pieces that are indistinguishable, and that's the sea sand that we see. And the same thing happens in academia or in life more generally, that the more friction you have with other people, the more you resemble them, and then you lose your authenticity, your unique critical thinking. And that's the kind of thing that I would hate to lose. So I try to remain as authentic, as close to my childhood as possible. And the one thing that bothered me a lot was that at the dinner table when I was a kid, I would ask a difficult question, and the adults in the room would dismiss it just because they didn't know the answer. They would say it's not important, then move on to another question. And I found that very frustrating. So becoming a scientist was a relief, because I can address any question on my own by collecting the evidence, by thinking about it independently. And that's what I enjoy. And tenure in academia is, in a way, allowing you not to worry about job security and just pursue what you think is important. And we can talk more about what I think is important.
Absolutely. I mean, but tell me as well, before we do, or this is something you think is important, I'm sure, but tell me where along the line from farm boy to Harvard and everything that came in between and everything that's going on now, whereabouts was it that you kind of had your mind opened or became interested in the phenomenon of UFO, UAP, and even extraterrestrial life, although I'm sure that maybe predates the UFO, UAP interest?
Well, in 2017, there was a report about, astronomers discovered the very first object from outside the solar system. It was a telescope in Hawaii named Pan-STARRS that identified a near-Earth object called Oumuamua. And because it was in Hawaii, the name means a scout in the Hawaiian language. I was intrigued because a decade earlier, I wrote the first scientific paper forecasting how many rocks we expect from other stars based on what we know about the solar system. And we didn't expect any detection by this telescope. And so that was surprising to me, because it implied that there is a much larger population of objects if this one arrived at random than we expected. And as time went on, this object became quite anomalous. It exhibited properties that we don't encounter with the typical rocks that we find in the solar system. So it didn't look like a comet or an asteroid. So that was my introduction to the subject, because at that point, when the object appeared to be most likely flat based on the reflection of sunlight, it exhibited an excess push away from the sun without showing a cometary tail, with no rocket effect acting on it. So I suggested maybe it is a very thin object, maybe it is artificial in origin. So that was the beginning of my interest in this subject. And then with my student in 2019, I was invited for a radio interview on a meteor that landed in the Bering Sea near Kamchatka, and it was 10 times, it released 10 times the energy of the Hiroshima atomic bomb. And in trying to learn about meteors, I looked online at what is known about them and so forth. And then I came across a data set, a catalog that the government compiled on meteors. And I asked my student, Amir Siraj, to check if any of them moves very fast, so that it must have originated from outside the solar system, just like Oumuamua was. And he looked and found that the second fastest object was definitely unbound to the sun. The fastest object was just a coincidence that it moved relative to Earth. It collided with Earth head on. So, but it was still potentially bound to the sun. The second fastest appeared to be clearly unbound and moved at 60 kilometers per second relative to the solar system when it was far away, based on what was measured by the government sensors. So we wrote a paper saying that this meteor that was detected back in January 8th, 2014, was interstellar in origin. And the paper was submitted for publication and rejected by the reviewers, who said, we don't believe the US government. And they didn't provide us access to the data, and therefore the paper cannot be published. And of course, the issue was the uncertainties. But in my mind, it was clear that the government, which is detecting objects as part of a missile warning system, needs to know whether a ballistic missile will hit Boston or New York City. They need to know very precisely the trajectory. So, but it took 3 years for me to convince some people within government to come out and confirm the assessment that we made. And that actually came out last month when a letter was submitted to NASA from the US Space Command under the Department of Defense, stating that at the 99.999% confidence, our statement that this meteor came from outside the solar system is correct. And moreover, the government also released the light curve of the fireball that was generated in the lower atmosphere. So from analyzing this fireball, we realized this object must be tougher than iron, actually, because it burned up only in the lower atmosphere. It was able to sustain a lot of stress all the way down to the lower atmosphere at 18.7 kilometers above sea level. And that makes it also an outlier, because only 5% of all meteors or space rocks are iron meteorites. So why would the first interstellar meteor belong to that 5%? And then it was also moving twice as fast outside the solar system compared to stars relative to the sun. So it was an outlier also in terms of its speed.
Yeah.
So what I'm saying is, two objects, Oumuamua and this meteor, appear to have been quite unusual relative to what we saw before in the solar system. And as a result, that's intriguing, because it's a message the universe is sending us that we are missing something about our cosmic neighborhood, because we imagine our cosmic neighborhood to be similar, to what we find near the sun, and that's probably not the case. I should also point out that in the 1960s, NASA was interested in potentially sending out an X-ray telescope to space, because you can't observe X-rays from the ground coming from space. And there was a committee assembled, and the committee of experts said that it makes little sense to invest so much funds in a space mission to detect X-rays from space, because we know that the sun produces X-rays, and what you might expect is other stars emitting X-rays like the sun. So we will not learn anything new. And so they said it's not worthwhile doing such a mission. But fortunately, a decade later, there was such a mission realized. And then we found that with that observatory, that in fact, there are many other sources we've never imagined. There are clusters of galaxies emitting X-rays. There are supernovae emitting X-rays. There are X-ray bursts. There is a huge zoo of potential sources we've never imagined. So my point is, thinking that what we find at our home, like our family members, represent the entire world, is not the correct approach, because very often you have a guest that tells you that there is something else out there.
Yeah.
And that was the intriguing thing for me. And as a result, then the government came out a year ago with, there was the director of national intelligence that reported about these unidentified aerial phenomena. And that that again attracted my attention. The head of NASA, Bill Nelson, said that scientists should engage and help government in figuring out the nature of these objects. So the following day, I actually contacted NASA and said, I'm happy to help. And then a month later, after a few multi-billionaires visited the porch of my home, gave me a couple of $1 million, no strings attached, I established the Galileo Project, which basically aims to identify the nature of objects near Earth that could be of technological origin. So that includes unidentified aerial phenomena. It includes objects like Oumuamua. It includes objects like this meteor. And within the coming months, we're planning actually to scoop the ocean floor near Papua and New Guinea, where this meteor landed. So it's very exciting, I must say. And it's sort of like taking a road that was never taken before. So there is a chance of finding low-hanging fruit simply because nobody took that road.
Yeah. I was reading about that you going to Papua New Guinea on this fishing trip, for want of a better word. Are you hoping to find something down there that might point to intelligent construction? Is that right?
Well, we know that this meteor was tougher than iron based on the fact that it burned up in the lower atmosphere. So it could be an iron meteorite. And in that case, we've seen objects. In fact, there was an expedition to the ocean, a different ocean, a few years ago to look for an iron meteorite. And what happens is when you have the fireball, the temperature is so high, it's thousands of degrees, so the iron melts. And then you end up with droplets that are tiny, the size of the head of a pin, less than a millimeter. And they rain down after the explosion. And, if you were to use an umbrella, it wouldn't protect you because these iron pellets would drill a hole through your umbrella. So this iron rain on the ocean obviously raises some steam when that takes place, but then those droplets sink to the ocean floor. And there you can actually scoop them. And one way to do that is using a sled with a magnet and then basically skimming the skin of the ocean floor, okay? And you just like mowing the lawn, you need to go back and forth many times. And the region would be of order 10 kilometers in size. It should be very exciting. Usually I get seasick on ships, but I'm willing to put my body on that ship for a long while until we collect those fragments. And then, of course, that would be quite exciting because we can analyze the composition of the object at the very least, not to speak about finding perhaps some bigger fragments.
Yeah. Wow. Yeah, that is exciting. And I think we all appreciate you putting your body on the line and risking sickness in the name of science and advancement. That's amazing. Before we move on to talk a bit more about the Galileo Project, let's dip into the recent congressional hearing.
Yeah. So my most important takeaway is that the government is discussing unidentified aerial phenomena, UAP, seriously and wishes to understand their nature. In my view, it's the duty of scientists as a result to assist the government in this quest and identify the unidentified and remove the term UAP from our lexicon. So there are two possible interpretations of unidentified technological objects. Either they were made by humans or they were made by extraterrestrial civilizations from outside of this Earth. In the first case, the government wishes to know which technologies are used by other nations. In the second case, the scientists would be interested in knowing which technologies are being employed or were developed by extraterrestrial civilizations. And obviously, the two witnesses in the congressional hearing were concerned with UAP as a threat to national security. And that's because their job definition involves protecting the safety of military personnel and the security of the nation. Okay, so from their perspective, reports by military staff members are of primary importance for the task of protecting the safety of them. And then the data from military training sites or patrol sites are linked to maintaining the security of the nation. And so they need to know what the vast majority of UAP are. And for that purpose, they must attend to all reports, to all data, even if it has compromised quality, like the blurry videos that were shared during the hearing.
Yeah.
But the task of scientists is complementary. Scientists do not need to explain all the reports, especially those with compromised quality. Who cares? Even if, but the important thing to keep in mind is that even if one object is of extraterrestrial technological origin among the clutter of many other objects that are human-made, that would represent, the discovery of this object would represent the most consequential discovery in human history, because its significance would resemble a first visit to the kindergarten, when you realize that there is a smarter kid on the block. Mm. And to figure this out, the scientists need to have access to the highest quality data. And that could include, for example, a high resolution image of an object that has the label made on exoplanet Y. Or you can see maneuver at a fraction of the speed of light. Or you can see a set of buttons that demonstrate the technical specification of a futuristic iPhone 100. So it's possible to tell if there is a piece of technology that was not made on this earth.
Yeah, absolutely. So tell me this. I mean, one of my takeaways from it, I don't know, maybe you think I'm wrong, but there was a moment where I just didn't know how to take it, right? Because they were asked about, by one of the congressional members, they were asked about the Malmstrom UFO, incident at the nuclear base. I'm sure that's something you've come across, where 10 nuclear missiles were shut down simultaneously. I actually had Robert Salas on the show to talk about it. But when they were asked that, I mean, in my opinion, they basically showed incompetence or an unwillingness to share any information on that with the public. Do you think that means we need to rely on organizations such as the Galileo Project for any hope of getting the truth or the reality of this phenomenon? Or do you think there's still a hope that the government are going to come through and genuinely share what they know? Because I don't think anybody's buying that they've not come across those cases, for example.
Oh, yeah. So I do think, their dilemma is that they have a network of sensors that are that use state-of-the-art technologies, and they don't want adversarial nations to be aware of the capabilities and the technologies being employed. So as a result, the data is classified. It's not because the content of the data is necessarily a matter of national security. It's just that the sensors that were used to obtain the data are classified. And that's what makes me think about the play by Samuel Beckett, Waiting for Godot, because if you wait for the government to declassify sensitive data, you might wait forever, okay? And it makes much more sense to get our own data, because the sky is not classified, and we should not hope that the government will serve science. It is the complementary duty of scientists to collect new data of higher quality. And by the way, those instruments in the cockpit of fighter jets or, on naval ships, they are not of the best quality one can imagine. And also the reports are anecdotal, and they come from those sites because that's where the military personnel patrol. It doesn't mean that such objects do not exist elsewhere, or completely unrelated to nuclear sites, because we don't often check those other regions. And the Galileo project that I lead, that I established after the report from the Director of National Intelligence was delivered to Congress in June 2021, aims to collect just that type of data. And this project is assembling its first telescope system on the roof of the Harvard College Observatory. And then once this system works, we will make copies of it and put them in various locations. And the system will monitor the sky continuously in the infrared, the visible and radio bands, as well as record the audio signals. And the data will be analyzed by state-of-the-art software using artificial intelligence and machine learning to identify objects in the sky and interpret their properties. And I think that's the way to go, because this data will be shared with all scientists. It will be open, and the interpretation of the data, will be transparent. So we're not dealing with government-owned sensors. We're not dealing with any issues related to national security, because we're looking, not necessarily near military or national assets. Mm-hmm. And I think that's the way to go. It's a fishing expedition, so we shouldn't assume in advance the nature of the fish that we will catch. But clearing up the fog about the nature of UAP is an important service to society, irrespective of what we find, because currently the public speculates. And the possibility that UAP are of extraterrestrial origin is not a wild speculation. Because, we sent out equipment to space. There are 5 spacecraft making their way out of the solar system. And most stars formed billions of years before the sun. And we know that half of the sun-like stars host a planet the size of the Earth at a similar separation. So that tells us that it would be arrogant for us to relax on the sofa at home and say, where is everybody? Without looking through our windows for any neighbors.
Yeah, I agree. And it's like you kind of mentioned it in there, but that's the easiest kind of response to somebody that says, oh, there's no chance, or that it's again, imagine if we had an extra 1,000 years, 10,000 years. I mean, like you said, 1 million years, 10 million years, like what could we come up with? We could just be, skimming stones across the galaxy, or just wherever we want to go, just at the drop of a hat. Who knows in what way we'd be doing it, but I'm sure by then we'll figure out a way. Let me ask, I've got one last question on these hearings the other day. And we can then move on to the Galileo Project in a little bit more detail. So this question is from Trevor, or Zorg Knows Best if you're on Twitter. During the hearing, Undersecretary of Defense for Intelligence and Security Ronald Moultrie mentioned he was committed to working with others, including NASA. Also, during a recent interview, Luis Elizondo, who is a research affiliate with the Galileo Project, mentioned that we should expect an announcement soon from NASA. Lou hinted at NASA taking an official role in the study of UAP, with the potential resources being made available. We've also seen Bill Nelson, the head of NASA, talking surprisingly openly about UAP. The question is, has there been any outreach from NASA or any individual associated with NASA to the Galileo Project regarding potential collaboration?
Not yet. I should say that before I established the Galileo Project, following the statement made by Bill Nelson, I approached the person under him that is responsible for science within NASA, Thomas Zubruchen, and I told him that I'm happy to help make his boss happy in the sense of working on the scientific aspects of the data that is available. I submitted a white paper to NASA. It was since then made public because of a Freedom of Information Act request. But I haven't received a response from NASA to my proposal. And as a result, I established the Galileo Project. I will be delighted to work with NASA. The one thing that was mentioned during the hearing is that NASA is interested in the search for extraterrestrial life. And that's, of course, correct. But it may be misleading because the search for UAP cannot be fulfilled by NASA's Perseverance rover surveying the surface of Mars, nor can it be fulfilled by searching for oxygen in the atmospheres of exoplanets. These are the kinds of things that are currently being discussed within the astronomy community. What we are dealing with in the context of UAP is a new quest for the unknown that did not receive proper attention by the scientific community so far.
Yeah.
And by the way, that includes also the community of scientists engaged in SETI, the search for extraterrestrial intelligence, because they focused primarily on technosignatures from other stars, such as radio or laser signals. But, it's just like saying, I want to learn about visitors in my backyard by looking at residents of New York City. It's completely different. Maybe the residents of New York City have nothing to do with the stranger that you find in your backyard. So the fact that NASA is looking for oxygen might be looking in the future within decades for oxygen or other molecules in the atmospheres of exoplanets, might be looking for other technosignatures. That's not really what we are talking about here. Here we're talking about objects next to us, close to us. And if we ever find such an object that is from an extraterrestrial technological origin beyond a reasonable doubt, it will bring a new challenge with it, because we don't have a protocol for how to respond to such a visitor. And, there is a fundamental question of who represents humanity, for example. We don't have an organization that will speak for all of us. And frankly, even if we had such an organization, it's quite possible that there would be some people that would act on their own. And they could potentially engage with such a functioning object, a visitor that perhaps has artificial intelligence. That's something that was not really thought about much. And there are issues related to policy and how to organize our engagement with such an object.
Yeah, no, absolutely. Do you think, or maybe I should say, do you expect NASA will, because Bill Nelson has been a change of pace, right? A breath of fresh air in that position with some of the things he said. So do you think there's a good chance, do you expect that NASA will maybe reach out to you guys, or will you be reaching out to them to talk about the phenomenon here on Earth, the UAP that we're witnessing?
Well, as I said, I already reached out, didn't get a response, but I very much hope that the lack of response was just that it takes them time to coordinate their response. And I very much hope that they will be on the ball soon. And I will be glad to collaborate with them. Because NASA is obviously has a lot of important scientific initiatives, and it would be wonderful to take advantage of their interest and funding for this purpose. I think we share a common goal. Both government and science can work together to figure out the nature of UAP, and this will advance our knowledge of the reality that we all share, well beyond the intricate politics of Washington, D.C. or academia, which we are often limited by.
Yeah. Okay. So I asked the UFOs sub on Reddit for some questions for you, and I had way more people than anticipated replying, and so many good questions. So thank you to everybody that asked, and apologies to those of you that I can't ask the question today. I've tried to trim them down to something that we can hopefully tackle today in the time we've got left. But maybe we won't be able to spend too long per question. So I guess we'll just try and keep it moving. So yeah, on the Galileo Project, it was a question about when's the first one going up. I read in your article, and you mentioned it just now, that the first one's going up this summer, hopefully next few weeks or months, on the roof of the Harvard Observatory. So to add on to that is, how many do you plan to install over the next year or two? Where will they be, and how do you decide where to install them?
Yeah, the number will simply reflect the level of funding that we have. And currently we have about $2 million that would allow us to make a few copies, because we have to support some people, salaries. So my hope is that we will get at least 10 times more funds at the level of tens of millions. And really, our wish is to have 100 million. That would allow us to build hundreds of telescope systems, which we calculated are needed to get good enough statistics based on the frequency of reports that were filed. And if we had the $100 million, we would definitely get to the bottom of this question of what's the nature of UAP, because we'll have enough data. And if you think about it, it's not a lot of money for a science project. For example, the Large Hadron Collider or the James Webb Space Telescope, these are the biggest science projects, they cost each of them $10 billion, okay? And that is 100 times more than I'm talking about. So for the cost of, and by the way, we use the Large Hadron Collider to search for supersymmetry. I mean, we found the Higgs boson, but we didn't find other things that we were hoping to find, like the nature of dark matter or supersymmetry. And, and here with an investment of 1% of that budget, we can learn a lot about those objects in the sky that currently are not identified. And even if we end up concluding that all the objects have mundane explanations, either they are human-made or they are natural in origin, that by itself is a very important service to society, both the government and the public, because we clear up the fog. We tell people, look, we obtained this high-quality data and we can identify those objects that are not from outside of this earth. And, so given the huge interest in this subject from the public and from government, investing $100 million in this quest is, in my mind, very well justified. Compared to the dark matter, if we find the nature of dark matter at the cost of $10 billion, it will have very little impact on our daily lives. Identifying the UAP would have much more potential impact on our daily life.
Yeah, absolutely. So how are you deciding where to put them? Is it just kind of you doing that research? Is there a team that are going to be deciding locations, or how's that working?
Yeah, we have a team within the Galileo Project that meets weekly and discusses various possibilities. And there are different considerations to take into account. One, it needs to be a site that we will have no legal issues with. We can't really put instruments on a military site or an asset that is of national significance. And access is another consideration. We need to be able to bring the equipment there easily and handle it. And also, it should be a place where there is good visibility and where reports were filed in the past about unusual objects. And so taking all of these into account, we will make a priority list. And then, of course, depending on how much funding we have, we will deploy those telescope systems.
Yeah. On that subject, I had like 2 or 3 people specifically mention the location Catalina Island. So I don't know if you kind of reveal, but is that somewhere that you're planning to put equipment?
Well, it's definitely a site of interest because of the Nimitz incident, and also because recently UAPX, a team of scientists, went there and just for 1 week and recorded some data, and they should come out with their scientific papers in the coming months. And so it would be good for us to compare what we find to what was reported before. But in terms of priority, it's not obvious to me that we want to go to necessarily to that place, because there might be activities there that are unrelated. And there might be also, the visibility is not necessarily the best. So we will think about it, of course. There were other clusters of UAP that, in other locations. So it's not obvious that this is the best choice for the first place. But it's definitely on our priority list to consider it. Yes.
Yeah. Okay. How much does one of the telescope systems cost? Approximately, right. if they're all slightly different, I don't know, but is there like a rough number?
That could change over time, because the first system cost us of order $250,000. Okay, but as we operate it, we will find ways of making it more efficient and less expensive. So doesn't mean that each system will cost the same. And we might also go for an array of systems that are of lower quality, but a larger number of them such that we get to sample more sites. Once again, it all depends on the funding level that we have.
Got you. Is it possible for private citizens to purchase or build one at home to help with the project? Obviously, it would be a select few, given the fact they're $250,000 a pop. But yeah, is that possible?
Yeah, well, definitely, if someone is interested in funding such a system at that level, they should approach me. We will not use citizen science contribution at this point in the sense of having a lot of people put something in their backyard, because I often get asked, people have cell phones, there are millions of cell phones, why don't we get more data on UAP just that way? And my point is, a cell phone has a very small aperture of only a few millimeters, so having 1 million low quality images is not equivalent to having one high quality image. Because all of these images will be fuzzy if you're talking about an object a mile away. And so it's not really about number, it's about quality. Okay. And of course, if someone is willing to invest the cost of a full system, they should approach me, and we'll be glad to collaborate. And that would, the more eyes we have looking at the sky with high quality instruments, the better.
Yeah. And if anybody does want to contact Avi and do that, then either get in touch with Avi, or you can email me and I'll make sure you put in touch with Avi. On the subject of funding, just a very quick question. Somebody asked, did Jeff Bezos, Elon Musk, have you managed to contact any of these, super rich, super famous billionaires that have got their own little space race going on? Has there been any contact there in regards to funding?
Well, I was with Jeff Bezos in the green room at the Washington National Cathedral. There was an event there, and both of us took part in a panel discussion. So I hope, I talked about the Galileo Project there, but I was not contacted by him afterwards. And I believe that Elon Musk, some people close to him that I was corresponding with made him aware of the Galileo Project. Haven't been contacted by him either. Of course, I would welcome very much any conversation with them, and if they're interested. We are following the scientific process. We are trying to collect evidence that will guide us, and at a relatively modest cost compared to the significance of any such discovery. So, I think it's an adventure, a scientific adventure, and it's like exploring the unknown. It's a fishing expedition. We don't know what fish we will catch, and it could be fun just to do it and see what happens. And if I were them, I would be thrilled to take part in such a thing.
Yeah, most definitely. Me too. Most definitely. Bob Bigelow's another one. I don't know whether you've spoken to him, but he's somebody that clearly has an interest in these subjects, and
once again, I know from people that are connected to him that he might be aware, but again, he didn't approach me, and so far, I'm basically responding to people showing interest, and I'm not trying to necessarily force my way to those people. So
not cold calling yet.
No, and it's really interesting. Like, for example, during the hearing, I had the request for 12 interviews in one day, and there is clearly a lot of awareness. My graduate student just came back from a trip to New York City. She was sitting next to some investor from Wall Street, and he was asking her, "So what do you do?" And she said, "Well, I'm actually doing a PhD in astronomy at Harvard University, and I'm working with Avi Loeb." And he said, "Really, you're working? That's amazing, because what he is talking about is so inspiring and such a breath of fresh air, and we are so supportive of him." So just by chance, she was sitting next to someone, and it seems like there is a lot of awareness of the effort that we are, and people are excited about it. So, people are getting the message that, what you see is what you get when you deal with me. I'm not trying to pretend. I'm not trying to manipulate people. I'm just trying to, figure out the reality that we all share based on evidence, which is pretty much the way science operates. It's the way kids operate, by the way. Kids don't listen to the adults in the room. And there are lots of adults in the room, especially in academia, all these experts that want to convince you that nothing is new under the sun, that anything in the sky would be space rocks, would be just because their expertise is rocks. And to me, it always reminds of the metaphor of a cave dweller that finds a cell phone and argues it's a rock of a type that we've never seen before. And if a cave dweller were to go to New York City, that cave dweller would be impressed by the gadgets and then come back to the cave and report about them, and they will become a myth of the family. But that cave dweller will never be able to reverse engineer all these gadgets. And so my point is, we shouldn't make any assumptions. We should just first check if there are any objects that are not natural or human-made. And then, of course, there is a question of what do they represent and how to respond to them. That's a second order question, but we can tell if something doesn't look like a bird, doesn't look like a drone, and behaves, maneuvers in ways that we cannot reproduce with our technologies.
Yeah, absolutely. Do you plan on monitoring the water or just the sky/space? The water, Sorry? Like oceans and stuff. Do you plan on having any telescopes monitoring like the oceans as well as?
So, we cannot really see through water, and putting cameras under the water is a completely different task. One can search with sonars, but the Galileo Project is not engaged with that, and we are primarily looking through the atmosphere or above the atmosphere in space. We have a second component of the Galileo Project aiming to design a space mission that will rendezvous with the next Oumuamua. So within a year, there will be the Vera Rubin Observatory in Chile that will have the Legacy Survey of Space and Time, LSST. And this telescope will have 3.2 billion pixels monitoring the entire sky every 4 days. And it will offer unprecedented sensitivity to objects like Oumuamua. And so the hope is that every few months it will uncover another interstellar object like Oumuamua. And with my postdoc, we're planning to develop the software that will identify those Oumuamua-like objects. It's sort of like developing a dating app. Most of the time we will swipe to the left, but every now and then we'll decide, okay, this is an object of great interest from an interstellar origin and that we want to monitor and perhaps even rendezvous with, go on a date. And so the second component is, of course, designing a space mission. And the Galileo Project received, through one of our members, Alan Stern, who was the principal investigator on the New Horizons mission to Pluto. He is now studying with a team of collaborators. He's studying the parameters of a space mission to rendezvous with an object like Oumuamua. And that would be the second facet of the Galileo Project, to go after objects that do not come close to Earth, but we can send a spacecraft that will come close to them so that we get a high resolution image and maybe even land on them. But that would cost at least $1 billion to do that, because the OSIRIS-REx mission cost $1.1 billion to land on the asteroid Bennu and to retrieve some sample from it that it will bring back to Earth in 2023. So actually, at a cost that is 1,000 times less than that, we can do the expedition near Papua New Guinea and search for the fragments from that meteor, the first interstellar meteor from 2014. So that's the third facet of the Galileo Project. And I think that will be the first one to actually deliver results. And we shall see what we find.
Yeah, I'm looking forward to results. Talking of results, when do you expect the first kind of papers, first data to be released? Will you be releasing data and papers based on just the one at the Harvard Observatory first, or will we have to wait until there's more set up?
So there will be a set of papers that are currently being prepared describing the instrumentation that we are developing, and related issues. And we hope to complete about 6 of those papers through the summer, so that we already have a special issue that will be dedicated to them in a prestigious journal, and that would be the report about the design of the telescope system and also the related issues, that is just the preparation, so to speak, what we did in the first year. And then, of course, in the second year, we will plan to get the new data that you are referring to. So that will be after the summer. Okay. And then, you know, the process is the standard scientific process where you collect the data, and then the team that analyzes the data needs typically a few months to just make sure that they trust the data, that they understand what the data means. And then, you know, the team writes a paper that is being peer reviewed in a scientific journal, and also the data will be released openly to anyone that wants to look at it. So that will be the procedure. And so my point is, within a year, such data should be available for anyone to look at. And of course, the more telescope systems we have, the more data we will have.
Yeah, great. Can't wait for that data. So just to be clear then, none of you haven't had any equipment so far that started scanning, started looking in the sky? Because this question is redundant then. There was going to be a question about whether you've got any evidence of you've seen anything, you know, unknown and things like that.
No. So the first system is assembled over the summer of 2022, and data collection will start after the summer.
Okay. Do you think June, July, August for this installation of the first system?
July 2022. Mm-hmm.
Cool. Okay. I had quite a few questions like this, so I've kind of amalgamated them into one. So if you do come across something world-changing, such as off-world vehicles, for example, will the government need to review the data before allowing you to release it? Will they try to or manage to control the narrative of what gets released? Or will you, in your opinion, obviously there's no way you can know for sure, but would you be completely open and totally transparent to the public? On that note, has anyone from the government talked to you about anything along these lines as of yet? And thanks, Avi, for all you do, they say.
Well, it's really interesting. It's really interesting. I was not contacted by anyone from government since the Galileo project was conceived. Now, you might interpret it in different ways, but they're definitely aware of that, because Senator Gillibrand, when she proposed the amendment that led to the establishment of a new office in June 2022, she referred to the Galileo project in the first version of the amendment, and I never spoke to her. So people in Washington, D.C. are definitely aware of the project. I just spoke on C-SPAN at Washington Journal a couple of hours ago. And, and yesterday I spoke at ABC News in Washington. They asked me about the hearing. So there is, and I publish in The Hill quite frequently. My commentaries are there. And so people are aware, definitely in Washington, but nobody contacted me. Okay, that's interesting. And moreover, I should say, we had this letter that came from the Department of Defense confirming the discovery of the first interstellar meteor. So, I have a good feeling that someone likes what we are doing out there. Nobody has a problem with it. And, since the sky is not classified, the only issue the government has is not to reveal the capabilities, the technological capabilities of the sensor being used to collect the data. And so they cannot really share the data for that reason alone, not because of what the data means. And, they should be pleased if a scientific collaboration, a scientific project collects data on its own. because astronomers do that all the time. We look at the sky, except the observatories that astronomers use focus on very distant objects. So if something flies by the observatory, astronomers ignore it. They don't have the facilities to follow it. And the Galileo Project had to develop its own instruments to do just that. Yeah. And so that's what makes it different from the standard practice in astronomy. I should mention an anecdote that when I got the funds from the donors and I wanted to deposit them in my research fund at Harvard, I was asked by administrators at Harvard, is this activity related to your daily job? Is that something that is related to your research in astronomy? And I thought about it and replied that, in fact, throughout the decades that I've been practicing astronomy, I was using data collected by telescopes and interpreting it. And that's exactly what the Galileo Project is doing. There is no lower limit on the distance of the objects of interest in astronomy. We are looking at the sun, we're looking at meteors, we're looking at asteroids, comets that are relatively nearby. So if we are using telescopes in the Galileo Project to look at objects within the Earth atmosphere, that can be regarded as part of astronomy because the data is collected by telescopes and then, we analyze the data. So the Harvard University administration agreed that it's part of my day job. And then we were able to establish the Galileo Project. So altogether, I think it's very exciting. I very much hope that this research agenda will become mainstream in astronomy, because if the public cares about these questions, the government now, based on the hearings, cares about them, how can the academic community shy away from it?
Mm. Yeah, no, I agree completely. Hopefully this is going to, like, your presence and the talking about it in government is all going to make it gradually easier and easier for people to get more involved and maybe just be open about the fact they have an interest in finding out what's going on. Because that's what it is. Like you say, it's just chasing the unknown, which is the fun part, right? That's the fascination.
And we talked earlier about putting my body on a ship near Papua New Guinea, but that relates to something that I encountered while serving in the military. That I parachuted early on in my military service. I was in the paratroopers, and I remember saying that sometimes a soldier needs to put his body on the barbed wire to allow others to pass through. And as much resistance as I get on social media or otherwise, it feels like a barbed wire to me. I mean, sometimes it's painful because the attacks are personal, but I look at the big picture, and these things are completely insignificant when you think about the importance of this question to the future of humanity.
Yeah. No, absolutely. So the last one on the kind of relates to Galileo before we jump into some more general UFO questions. So the Galileo Project is a comprehensive and hard scientific research project that is funded and staffed at one of the best institutions on the planet. As you said, not entirely staffed. But the reality is not all institutions have that luxury. Question: does Avi have any recommendations for researchers who want to contribute to this topic but have limited or very limited resources? Specifically, what kind of qualitative research would Avi recommend that could be useful within the Galileo Project or the topic as a whole?
So on the Galileo Project website, we have a tab that allows people to volunteer to be part of it.
Which description, by the way, I'll just mention that.
Yeah, and then we got... of all the 800 people fill this form, so we can't accommodate everyone, but we definitely go through each and every application. And, when we need the expertise that is mentioned in the form, we approach the people of interest. So there is a way to contribute to the project, and just go to the Galileo Project website, you will find the tab. Yeah.
Great. So again, I had lots of questions like this one, which I've kind of again tried to summarize. Do you have an opinion on the question of why secrecy, why potential cover-up? Because even from the point of view of there is no cover-up, things are still clearly held back. That's beyond dispute. So you kind of alluded to the fact that you think it's purely the censors, that they don't want to give away national security information. Do you think there's anything more to it, such as money or, power, anything more nefarious?
No, I mean, the only other thing I can think of is there might be technologies being developed by, some sections of government that other sections are not aware of. Mm-hmm. And perhaps, some equipment is being tested. Okay, so not everyone is aware that the equipment is being tested. And then, Navy staff, pilots or military personnel, they notice things that they're not aware of, okay? And then it looks as if there is something unusual going on, but it's actually one other branch of government that is not informing everyone else about its activities, okay? Yeah. And that's quite possible. And that could also explain why some records were erased, deleted, or taken away. It's not because of a conspiracy, but just because someone else knows that whatever was seen, belongs to some other section of government. Okay, that it's not an adversary, and so I would think that is a very real possibility, especially if secret technological programs are being developed and you want to test some equipment, but you don't want to tell everyone that you're testing it. So you're testing it, and then others are noticing it and asking questions about it. So that would be a very reasonable explanation to some of the incidents. So altogether, the UAP might be a mixed bag. Some incidents may be of this type, others may be, civilian objects like balloons, drones that the military is not aware of, or there could also be equipment from other nations trying to spy on the US that we are not aware of. And but beyond that, there might be something else. That's as a scientist what intrigues me, and that's what we should find out. Now, I don't believe that the government is covering up, as part of a conspiracy, because I don't think the government is competent enough to keep a secret for so long. And I would argue that it's most likely that they are puzzled, people looking at it, or some of the reports were originated from equipment that was malfunctioning, that was not really doing, or was misinterpreted. So that's why I think, let's forget about low quality data obtained over the decades. Okay, now we have much better instruments that we can use. Let's use top of the line instruments and, survey the sky without any prejudice and figure out what's out there, rather than waiting for the government to declassify some data that was taken 10 years ago by instruments that are of lower quality than we have on a cockpit of a fighter jet that was maneuvering itself. So how can you separate what happened to the camera from what happened, from the motion of the object itself? So it complicates matters. And of course, the military people really want to protect their personnel. They want to, they're worried about national security. And so they would focus on that data. But as a scientist, I would much rather collect new data.
Yeah. No, exactly. New data that you're able to share, which is the key and the best part, right? Then we can have discussion about it. What are your thoughts on UAP and their seemingly over interest in shadowing nuclear assets such as submarines, missile silos, even power stations, but the nuclear connection?
So if you look at the population of UAP reports, okay, it seems to be to zeroth order correlated with the population density. Okay, so there is a very simple interpretation of that. The more people look at the sky, the more reports you have. And I would argue that, military assets or nuclear facilities are being monitored much more than other places. And as a result, we get more reports. So the zeroth order, as far as I know, is simply the regions that we monitor more frequently, we see more UAP in. And that's consistent with the idea that they are everywhere. Yeah. Okay. And of course, hackers might want, or adversaries might want to focus on military facilities as well, but I didn't see evidence, I didn't see a comparison between just a random place in the middle of the country versus a military facility, and just putting the same instruments in both, patrolling the sky in the same way in both, and comparing the rate of UAP. I haven't seen that, but from what citizens report, it's clear that you have a tight correlation between the population density and the number of reports per unit time.
Yeah. I guess it's just a little bit of a question of like chicken or the egg. Is it the UAP interested in the nuclear assets, or is it the fact that they're monitoring the area so closely that they notice, more UAP?
Well, it's very easy. It's very easy to test that by putting, if the Galileo project has enough telescope systems, we just put them in different locations and we see, and we check that hypothesis. And, if we find the same rate of incidence of events in all places, then it has nothing to do with the nuclear facilities.
Yeah, again, can't wait to see. What kind of historic data should be analyzed, in your opinion, in relation to unidentified aerial phenomena?
Well, my preference, just like a kid, I want to get my own data, because then I can trust it. I know how it was collected. I can control the quality of the data. If any of these witnesses, at the hearing, the congressional hearing, were to share their data, they showed some fuzzy, blurry videos. Okay. Now you never know what the camera was doing at the time the video was taken. You don't know, whether it might be some optical illusion or that there was no control. I mean, it's not a scientific experiment because it's the cockpit of a fighter jet, and when the Galileo Project constructs an experiment, we have all the instruments under full control. We know exactly what they're doing. We compare different parts of the sky, and when we see something unusual, we'll understand it much better. So it's not at all clear that analyzing past data that was anecdotal, the government is not really after studying UAP. They just patrol the sky and every now and then see something unusual, okay, by chance. That's not the right way to address it. What you want is to build in instruments that are much more sensitive than you carry with you in a cockpit, and that do it on a routine basis, irrespective of whether someone is patrolling it at that time or not. Just do it all the time. And then you can understand what it means. So rather than obsess with what the government is telling us and wait for them to release the high quality data, let's just bring this to a much better footing of having open data of higher quality shared with everyone.
Yeah. What might the odds be? This is from a physics graduate, I think, that said there. Ask him this one all-important question. What might the odds be, the odds truly be, that the laws of physics allow for any kind of faster-than-light travel? And I'll kind of qualify it so you don't, by saying, are the odds zero or are they non-zero?
The odds are never zero, because we know that the standard model of physics is incomplete. So it's incomplete because we don't have a unified theory of quantum mechanics and gravity. And, Einstein's theory of gravity has singularities. There are, places where it breaks down, like inside a black hole or at the Big Bang. So we know that we don't have the complete theory of nature. There were proposals how to marry quantum mechanics with gravity, but none of them was tested. And so we don't have that understanding. And until we have the complete understanding of quantum mechanics and gravity, we would never be able to tell if you can move faster than light between 2 points in space and time, okay? And because the structure of space and time could be rather complicated, okay? And so I would hesitate to say that, it's not possible. And the other thing we don't know is like what is most of the matter in the universe. We call it the dark matter. We don't know what it's made of. Now, if we knew what it is, and we've been trying to understand it since 1933, when Fritz Zwicky first argued that it exists in clusters of galaxies, and over the past half century, we had experiments trying to look for it. We haven't found it yet. But suppose that another civilization knows what the dark matter is, and in principle, if they can engineer it, they might be using it for fuel because it's everywhere, Mm-hmm. And then if we see a vehicle that nothing comes out of its exhaust, It may well be because this is invisible matter, the dark matter we know exists. Maybe they're using it for propulsion. Yeah. By the way, speaking about that, I just wrote a paper a few days ago. There is a theory that is an alternative to dark matter that says instead of having missing matter, the law of inertia is modified at very low acceleration. So you can show that you get flat rotation curves in galaxies without dark matter if the inertia is reduced at low acceleration. So, you get more, you get sort of a free lunch for the same gravitational force, you get more effect at low accelerations and more. So I said, well, if that's the case, then you can build a rocket that operates at low accelerations, and then you don't need to carry much fuel in order to propel it. If you propel it at low accelerations, it will get to very high speeds without much fuel. The usual problem with the rocket equation is that you need exponentially more fuel if you want to increase the terminal speed of the payload. It goes exponentially with, that's called the rocket equation that was derived more than a century ago. We know that as a result, all the rockets that we launched to space achieved roughly the same terminal speeds of tens of kilometers per second, nothing beyond that, because that's 10 times more than the exhaust speed, the speed of the gas when it's ejected from the exhaust of the rocket. And you can't go much faster than that because you would require much more fuel, exponentially more fuel as you increase the speed. But if indeed the behavior of matter at low accelerations is such that you don't need dark matter, but the inertia is reduced, I showed that, in fact, you can build rockets that would reach the distances between galaxies, intergalactic distances, with a very modest amount of fuel comparable to the mass of the payload. And, that's new physics. Okay, if that's the case, if indeed there is no dark matter and inertia is modified, then rockets can traverse the huge distances of millions of light years between galaxies with fuel that it has roughly the same mass as the payload, which is unheard of in terms of the rocket equation. So what I'm saying is that we know that our physics, our understanding of the physical world is incomplete, and there could be surprises, and we should be modest. So even though we award the Nobel Prize to discoveries, and a lot of physicists would argue, we had so many accomplishments over the past century, I would argue that, it's just representing an island of knowledge in an ocean of ignorance. Okay. And so there is a lot that we don't understand because we only had the modern science and technology for a century. And just imagine another civilization that had it for 1 million years or 1 billion years. If we ever meet any equipment that they send, if the technological gap is huge, it would appear like magic to us. We wouldn't be able to understand it or reverse engineer it. And we could learn from them. So that's an opportunity. It's a learning experience.
If the gap's not too big, like you said, with the caveman and the iPhone, we'll have to hope it's not too far. We've got 4 questions left, so hopefully I'm going to get to these in the last 10 minutes I've got with you. So here's the last long question. I've seen you mention before that I've just added that at the start because you mentioned earlier about the clutter and we only need to prove one. So on that note, Oumuamua was spotted at a distance of 21 million miles from Earth. Avi believes it could be extraterrestrial in origin. Nearest solar system to ours is Alpha Centauri at 4.37 light years. So, if this probe came within 21 million miles of Earth, it traveled 99.999% of the way to Earth and never visited. Given this fact, does Avi believe that we've likely been visited before, as in at some point in time, at least one singular alien craft has touched down on our planet or entered our atmosphere?
Quite possibly. And that's why we should study this UAP to figure it out. My point is, a very advanced scientific civilization could be a good approximation to God, what religious texts call God, because it will represent technologies that are far more advanced than we can imagine. And, the sky is the limit. So rather than arguing about it the way a lot of people do, let's just use evidence to guide us. That was the main message that Galileo Galilei delivered 4 centuries ago. He said, look through my telescope and you'd realize that the Earth moves around the sun. But the philosophers insisted that they put him in house arrest, and they said, we don't want others to listen to you. And today they would have canceled him on social media. But if you were to ask those philosophers to design a space mission to Mars, they would never reach the destination because they thought that Mars moves around the Earth.
Does Avi subscribe to the dark forest theory? If not, what is his perspective? Thank you. A lot of these have added a thanks, which I've cut off. So they're all saying thank you, Avi. They're all saying thanks for your work. Thanks for your service. But yeah, dark forest theory.
Yeah, so I don't have a favorite explanation to why, it's not obvious to us that we have neighbors. And of course, that's one possibility. But what I should say is, things that we call ordinary are easy to see. Okay, so for example, we see birds every day. Okay, if you look out, and they appear to be ordinary. If you ask any person, they would say, "Oh, birds in the sky, that's an ordinary sight. This is part of our reality." Mm-hmm. But if you think about it more deeply, you realize that humans were able to, replicate the abilities of birds to fly only in 1903 when the Wright brothers had the first flight. Okay, so It's completely non-trivial to fly in air. Okay, so even though we regard it as an ordinary sight, the physics behind it is non-trivial. Okay, and my point is that the distinction between ordinary and extraordinary is based on societal conventions, and it may well be that when we say finding a craft from another civilization is an extraordinary claim. This is just because it requires us to pay attention to our environment and detect such objects. And we haven't done that. When Enrico Fermi asked, where is everybody? He didn't use a telescope. He was just like a person sitting at home on the sofa and saying, I don't hear a knock on my door, therefore I don't have neighbors. But to see your neighbors, you need to look out. And that's what we did for the first time in the past decade. You see, before Pan-STARRS that discovered Oumuamua, we didn't have a survey telescope that could find an object the size of a football field. And even about Oumuamua, which passed through the orbit of the Earth around the sun, even about that, it was discovered just because it came close to Earth. Okay, so the Pan-STARRS telescope was tasked with finding near-Earth objects, and Oumuamua happened to pass close to Earth, and therefore astronomers paid attention to it and measured its speed, and then realized, oh, it's not bound to the sun. But imagine it passing a little farther away, they wouldn't have tagged it as interesting. And it's really fascinating because there is this huge flood of data that will come from the Vera Rubin Observatory. And I spoke with a postdoc that plans to use it, and I asked him, how would you analyze the data? And he said, we will analyze only look for objects that are bound to the sun. And I found that really strange that, you put these blinders to start with. And, people also say, Oumuamua, okay, it moved twice as fast as comets or asteroids move in the solar system that are bound to the sun. So it was not very unusual. My point is, if it were moving at a fraction of the speed of light, nobody would have reported about it because people would say, oh, there is something out there that moves too fast. It's not part of our algorithm of identifying objects. It's probably just a fluke. So when you say something looks similar to previous objects that we found, it's just because we were looking for things that look like objects we found before. And that's why, by chance, we found Oumuamua, which happened to be actually anomalous in all other respects. So the fact that it moved twice as fast and not 100 times faster than the rocks in the solar system is just a selection effect. Astronomers would never tag it as interesting if it were moving much faster.
So you don't think, in short, you don't think we're making a mistake by sending our messages out there? You don't think we're inviting some dangerous guests? You're not worried about the risk?
I mean, we already did that. We already sent all these messages. I'm not worried because I don't think that we are that sophisticated in the class of intelligent civilizations within the Milky Way galaxy. I don't think that we are the brightest one in that class. And I usually tell my students at Harvard, half of you are below the median because, in statistics, the median is always defined such that half of any class is below the median. They have a hard time accepting it because Harvard students want to believe that all of them are at the top 1%. And actually, we as a civilization have this tendency as well to think that we are very intelligent, very sophisticated. I don't think that we are that interesting, I would argue that there are lots of things like us that existed billions of years ago, and they may not be around anymore. Look how we behave. I would be really glad if we survived for a few more centuries.
Yeah, I think we'll be pretty lucky if we make it that far. But I think we're pretty interesting. Not to stay on this point because I do need to move on. But I have to say I think we're pretty interesting, right? I think some people travel miles to study ants and flies and things like that. We've got music, culture. We hate each other. We love each other. We make jokes.
Okay. So here is my experimental test for that. Let's see how attractive we are in the galactic dating scene. Okay. So if we find others interested in us, then I would agree with you. But if we keep finding and nobody cares about us, I would disagree.
Yeah.
So just like trying to date, and you realize based on you realize your market value based on how much interest you raise.
Yeah. I guess hopefully one day we'll see. So this is the penultimate question here. So I would love to know to what extent Avi feels the general public overestimates our scientific knowledge of existence. Secondarily, why does he think this is?
Well, I do think that the scientific community in academia overstates its knowledge. And for a simple reason, that people are attached to their ego. They maximize their chances for getting honors and awards. They don't want to advertise their level of ignorance. So first of all, experts always explain whatever we find in terms of what was found before. And if there is something unusual happening, they would raise enough dust and claim that they don't see anything. Okay, so that's a natural tendency. You see it all over the place. And that's why discoveries are not made very often, because you have this agenda of quote unquote experts to maintain their status by claiming that there is nothing new under the sun. And that's unfortunate. If we were all modest and humble and, we wouldn't care so much about our ego, and we would pay attention to anomalies as they come along and try to explain them by getting more data, then we would make much more progress. And my hope is, by the way, that AI systems, artificial intelligence scientists, would behave much better than human scientists, because they might not be attached to their ego as much as humans are. So if you feed AI systems with data and they see an object that doesn't behave like a rock, then the AI system will say, doesn't look like a rock. And then if there is another system, as the one discovered in September 2020, that shared the same qualities as Oumuamua and ended up being a rocket booster that we launched in 1966, discovered by the same telescope in Hawaii, Pan-STARRS. So this AI system will say, hey, look, there is this object 2020 SO discovered a couple of years later. It looks exactly like Oumuamua in terms of its qualities. Maybe they are both artificial. However, the human scientists never published a paper about 2020 SO, never connected the dots, insisted that Oumuamua must be natural in origin. It's just a rock of a type that we've never seen before. It's either a hydrogen iceberg, it's a dust bunny, or it's a nitrogen iceberg, but it's natural. Forget about any other interpretation, and didn't even write a paper about 2020 SO. My hope is an AI system will look at it, at all the facts and just say, okay, well, it's a valid hypothesis since 2020 SO that we launched share qualities with Oumuamua. Perhaps Oumuamua was a technological relic, and that's it. And the AI system will publish a paper, not get ridiculed by other AI systems, not have dislikes on Twitter because it's just an AI system. So perhaps the future is brighter if we were to remove the human ego from the equation and just rely on data and evidence.
Yeah, that's true. So last question, Avi. Does Avi live his life any differently today than, say, 10 years ago with regards to his belief in what we may find out there? And has it affected his thinking, lifestyle, etc.?
Definitely. I'm much more excited about the prospects of finding something unusual, given the evidence about the two interstellar objects that were just discovered over the past decade and we didn't know about before. Okay, so that's a completely new way of searching for other civilizations that was never practiced before. We searched for radio signals for 70 years. We haven't found any. So it gives me hope that, this is a path that was not taken. We will have some discoveries. And my personal life, over the past year or two, actually, since the pandemic started, is quite different in the sense that, over the past year, I had 2,500 interviews. I had a huge interest from the public in what I do. I had a lot of pushback from people in academia, many of which are relatively junior. They're not familiar with the body of work that I did on black holes, on cosmology. I wrote nearly 1,000 scientific papers, published 8 books. They never went back to see what those things. They just made statements, and it's a bit disappointing that, given social media, people can raise their voice without doing their homework first and realizing, who they're speaking with. That's disappointing, but given, it's at the same time, I'm getting a huge reinforcement from other sections of society. And it looks like, we are on track to doing exciting work, scientific work, following the scientific method. I'm just disappointed that some scientists, even though they are scientists, they're not following the scientific method.
Yeah. Well, like you say, hopefully you're going to lead this new charge of science and discover some of these unknowns, these magically mysterious unknowns. If you've got any last words or any message you want to pass to anybody listening, watching today?
Yeah, especially to the young generation that is not trapped by ego or by baggage, past beliefs. I think there is a lot of discovery room, and I very much hope that the new generation will bring a better future in terms of our knowledge of the reality that we live in. Because after all, it's all about adapting to the reality that we live in. 1,000 years ago, there were people arguing that the human body has a soul and therefore anatomy should be forbidden. But now all of modern medicine is based on our ability to dissect the human body, to do operations, and we figure out how it works. We, as a result, develop mRNA vaccines to viruses, And my point is, you can adapt to reality only if you understand it, if you follow the evidence. And that should be the guiding principle, that to allow nature to educate us, okay? And I think young people have that in mind. It's just that as they become adults, they get attached to their ego too much, and they become experts, and they're not, they pretend to behave like the adults in the room. And as I said, I didn't change my frustration from the time that I was a kid with the adults in the room. We are all children. We are all being educated by nature. Let's allow nature to teach us what's out there, rather than assume that we know the answer in advance and aim to get more awards and honors, just pretending that we know the answer in advance.
Brilliant. Keep the childlike curiosity. It's important.
Exactly.
Thank you so much for today, Avi. This was brilliant. I really enjoyed talking to you. I really appreciate your time.
My pleasure. Thank you.
Thank you for listening to my chat with Avi Loeb. I hope you enjoyed it and learned something new. Thank you to the UFOs community on Reddit for lots of the great questions. Stay curious, stay open-minded, and please subscribe to join us on our journey to unravel the universe.